Welcome to qnawire.
We have been given a data set. We want to use it as a sample that will give us an estimate of the population mean. Okay, so I'll start with the formula. This is the formula for a confidence interval for a population mean. It is x bar, point estimate, sample mean, plus minus the margin of error, ts over root n. T is the critical value. We're using that because sigma is unknown. And sigma is the population standard deviation. We haven't been given that, we're going to have to use the sample standard deviation. So we have to use t. So we need to find these four values. N is the sample size, just 14. To find x bar, you take each value, you add them up, you divide by the total. If I add these up, I get 229. I'll just leave this as 229 over 14. To get the sample standard deviation, you take each value, you subtract the mean, you square the difference, sum the squares, divide by n minus 1, square root the result. Note, n minus 1 because it's a sample. If it were a population, as you're finding the population standard deviation, it would just be n. This is very much busy work. Feel free to just make your calculator do this bit if you like. But this is 14.521 and so on. I've got the exact value in my calculator. And t. So to get t, you need to know the degrees of freedom, which for a one sample t interval is just n minus 1, so that's 13. And alpha over 2, which is 1 minus the confidence over 2. We want 99% confidence. So alpha, the sum of the tails, is 1%, and each tail is 0.5%. So we're looking for t sub 0.005, 13 degrees of freedom. You can get that from a t-value table or from software. It is 3.012. Now we use this formula. So we've got x bar plus minus. I'm going to get the error now. So I've got my standard deviation multiplied by 3.012 and divided by root 14, which is 11.6894. Now, if I subtract that away from the point estimate, I get the lower bound of my interval, 4.67. If I add it onto my point estimate, I get the upper bound, 28.05. And there is our confidence interval for the population mean. We are 99% confident the population mean is in that interval.